All right, welcome everyone. We're going to get started here shortly. I'm checking in on some technical issues with Dr. Lolato's mic. For those of you who are unfamiliar with the project, Great Plains Grazing is a USDA coordinated agriculture project focused on beef cattle or the grazing end of beef cattle production. And today, Dr. Romulo Lolato will be speaking about managing grazing timing and intensity in dual-purpose wheat systems.
As part of this webinar, I'll discuss in dual-purpose situation, including not only grazing initiation, management, and grazing termination as well, but I'll also discuss some of the wheat managements that are specific for dual-purpose systems and how these differ whenever we're talking about grain only or dual-purpose wheat production. So most of the information that I'll share with you today comes from some grazing research that was done either at Kansas State University or at Oklahoma State University, and I'll also be providing the winter wheat as a forage system in the wheat for both forage and grain. And most of my time I'll spend on these two first topics. I'll also discuss some of wheat variety selection. So what are some of the interesting traits that we need to be looking for whenever we're going into the dual-purpose situation? And finally, I will also discuss some thoughts on using a smartphone application, Canopeo, to manage grazing intensity. So how can we use this tool to help us avoid overgrazing? So going into the first topic here, winter wheat is a forage system in the Southern Plains. So for the sake of this presentation, the Southern Plains would be considered the region encompassing most of Kansas, Oklahoma, and Texas. These three states combined sow about 20 million acres of winter wheat every year. And there's been some previous work that has estimated that from these 20 million acres that are sown every year, as much as about 8 million acres may be grazed. So this really highlights the importance of wheat pastures in this region. Now, reasons why winter wheat can be grazed mostly in this region, and which makes this region unique as compared to other regions in the world, is because temperatures are generally favorable to wheat growth well into winter months. So if we think that wheat has a base temperature of 32 Fahrenheit, and base temperature meaning that that's the temperature below which there's really no growth, and we start to think, well, how many days is our average temperature in this region actually below 32, right? And as we start to answer this question, we start to understand that there can be some growth even during the winter months in this region, which allow us to go ahead and graze the wheat pastures. In fact, anywhere from about 120 to 150 days during the growing season allows for a grazable wheat pasture, so allows us to have cattle on top of the wheat in this region. Now, as far as forage production by the wheat crop, some studies conducted in Kansas and Oklahoma indicate that about 2,000 to 4,000 pounds of dry forage per acre may be produced during the fall, and this means prior to winter dormancy. Obviously, this will depend on several factors. So we're talking about planting date, seeding rate, soil fertility, especially soil pH, as you can see here on the right-hand side on this picture, will play a major role in wheat forage production. And some of these practical aspects I will discuss here in the second portion of the presentation. But here, really, I just wanted to highlight that there are environmental differences, right? So the environment will really dictate how much forage we're going to produce. And these are mostly going to be led by temperature and precipitation during the fall and winter. And so the environment will have a huge impact on the amount of forage produced. There are a variety of differences as well as far as the amount of forage production. Finally, I also wanted to say that not only 2,000 to 4,000 pounds of dry forage can be produced per acre, but also there is a very high quality forage. So, and it's a high quality forage that is being produced during a time of the year whenever other forage sources are low in either quantity or quality. And this time of the year is generally anywhere from starting to graze in about November or December, depending where we are, grazing throughout the winter months, and sometimes as far as early spring. So as grazing is often terminated between mid-February and early March. So when considering wheat forage, so as I was saying, so there's been some previous research done here in Southwest Kansas, actually, that has shown that the wheat forage is of premium quality, even when compared with other grass hay, or even when compared with alfalfa, which is considered the queen of the forages here. So whenever we look a little bit deeper into the quality aspects of wheat forage, it often has anywhere from 20 to 30% crude protein, less than 25% acid detergent fibers. As I was saying, generally less than about 25% of acid detergent fibers, and here it's mostly cellulose and lignin. Less than 45% nutrient-detergent fibers, which are mostly cell wall components, and as high as about 80% of total digestible nutrients. So wheat forage will decrease with the progress of the crop. So as the crop moves toward physiological maturity, especially, so if we're past that grazing period on dual-purpose systems, the quality will go down, especially fiber content going up and the overall digestibility and protein concentration decreasing. But again, we're talking about dual-purpose systems, and so we're actually grazing in a period when wheat quality is really high, with forage quality. Now, many producers may have questions about the effects of grazing on the wheat crop, right? Especially those producers who maybe are now grain-only producers but have considered going to a dual-purpose system, or even those who are now grazing their wheat crop but are also concerned with harvesting grain. So some of the effects that we can talk on of grazing on the wheat crop are, first, a slight delay in maturity. So as you can see here, often grazing will delay anywhere from 1 to about 4 days in maturity. And although this may seem like not like much, those who have been around the region long enough know how it can get hot towards the end of the wheat crop cycle. So grazing can, to a certain extent, increase high temperature stress during grain field because of this delayed maturity. In other cases, in years, for example, when there's an early freeze, this slight delay in maturity can also be beneficial to yields, just by avoiding the freeze event if that freeze occurs early during the spring. So delaying maturity is one of the consequences of grazing wheat crop. Grazing will also decrease the number of stems, right, or tillers, by two main means here. One of them, cattle removal by grazing itself, but also due to trampling of plants, especially if grazing in moist soil conditions. So let's focus only on the grazing and on the removal of that biomass. This decreased top growth in years when it can be either beneficial or can be bad for grain yields as well. It's going to depend. So in years when grazing termination is followed by a favorable weather, that decreased biomass can hurt some of the yields, most likely because the weather will have been enough to sustain that excess biomass. So there will be enough spring moisture to sustain wheat grain yields despite the amount of biomass. On the other hand, so that grazing could possibly hurt our wheat yields. Now, on the other hand, if the spring turns out to be really dry, that biomass removal may actually benefit the wheat grain yield as well, because the crop is not going to have that lush development, the lush vegetative growth, which would require an abundant amount of water to be sustained. So some situations when the growing season turns out very harsh during the spring, maybe due to dry conditions or maybe due to spring freeze, wheat yields can benefit from this biomass removal by grazing. So I guess to answer that question, if the wheat yields are going to be affected by grazing, we can look back at some research done by Oklahoma State University's Jeff Edwards and some of his colleagues. So here in this research, they summarize about 20 years of grazing wheat research data from Marshall, which is north central Oklahoma. So this research was done with the variety performance tests, where there are testing several varieties under both grazed or ungrazed systems in neighboring trials here. So in this very first chart that I'm showing you, they summarize data from 1991 until 1998, and both grazed and ungrazed plots were sown in September. So we're actually looking at a little bit earlier than optimal planting date for our grain only here, right? So we're just looking at the effect of grazing. So in this situation, the early planted grazed versus ungrazed wheat, there was an average decrease in about 7% yield, grain yield in high yielding environments. And this aligns really well with what I just said in the last slide here. These were most likely environments with favorable spring weather during which grazing decreased grain yields. So in their analysis here as well, on the other extreme, there was a slight yield increase in low yielding environments, which again may be due to delayed wheat development, in case these low yielding environments were due to spring freeze, or can also be due to that removal of the excess biomass in case we had drought later during the growing season. Moving on in their research as well, and comparing now the dual purpose system. So the remaining of the data that I'm showing here, we're actually comparing the system which in dual purpose is sown early during September at a seeding density of about 120 pounds per acre, and grazed versus grain only, which was planted in October at a lower seeding rate, about 60 pounds per acre. So this data from 1999 until 2010 really suggests an average yield decrease of 14% associated with the dual purpose system. So not only the grazing, but actually the system. So considering the previous slide in which there was about 7% yield decrease due to the grazing only, this data really indicates that about half to a third or a third to half of the yield losses that are generally associated with the dual purpose system are caused by grazing, and the remaining proportion of that yield loss is actually associated with an earlier than optimal planting date. So again, this large data set indicating an overall yield penalty of about 14% due to the dual purpose system itself. Now, one factor that is very crucial and we need to take into account in determining whether wheat recovery potential from grazing during early spring and then for the grain yields as well is the amount of green leaves remaining in the wheat crop at time of grazing termination. So if you take a look at this research here that was also done by Edwards Group, the bottom graph showing us that maintaining about 60% fractional green canopy cover at timing of graze termination or first hollow stem was really crucial to help sustain these yield levels comparable to an ungrazed control. Again, the environmental conditions at grazing termination will affect the recovery of the wheat from grazing. Better recovery will occur under cool and wet conditions. But why is green canopy cover important at grazing termination? So as we think about the green leaves, they're actually the factory, right, that the crop has to produce some carbohydrates and recover from grazing. And it's highly correlated with light interception, water use, or even more specifically the partitioning between evaporation and transpiration, as you can see in the slide. And also the crop leaf area index. So the greater the defoliation that we have at grazing termination, the worse are the chances of full recovery by the crop. So really our main message here is that maintaining adequate green canopy cover at termination is really important when we're considering the grazed wheat crop going for grain. So our conclusions here is that whether grazing will affect wheat grain yield or not, it's really going to depend on several factors, including wheat management, grazing management, soil nutrient status, and also the weather during the spring. So let's go ahead and go a little bit more in depth into some of these subjects, moving on to the second part of this webinar here, where we'll discuss management of the wheat crop as well as livestock when the wheat is grown for dual purpose. So wheat, whenever it's grown for dual purpose, it requires a different management practice than that wheat grown for grain only. And the first management practice that I would like to discuss here are planting date and seeding rate. So this graph, it shows wheat fall forage yield as affected by seeding date and by planting date as well. Seeding rate and planting date, sorry. Data was collected from north central Oklahoma, so it's probably representative of that area, south central Kansas, north central Oklahoma, from 1991 to 1994 here. And what is clear from this chart is that fall forage production is much greater at earlier planting dates, as shown by the black data as well as by the red circle. So the black squares, they are 28th of August planting date, and the red circles are 11th of September. These graphs also showing us that wheat sown after September 25th in this region have very little potential for fall forage production in most years. And this data is summarized in green and blue here, so very, very reduced forage production. What else is this graph showing us? So these curves are also showing us that increasing seeding rate to about 120 pounds per acre increased forage production regardless of the planting date, and also that switching from about 90 to 120 pounds of seed per acre generally justified the additional cost of the seed because of the amount of biomass, extra biomass that was produced. So to maximize wheat fall forage production for that central region, here's that seeding at about 120 pounds per acre should be adequate for this central region of the southern Great Plains. And the earlier the planting date, the more forage will be produced. So it's interesting to notice that the laying planting date in 2 weeks here, as you can see by the purple arrow, from September 11th to September 25th, decreased fall forage production about 1,000 pounds per acre. So it's a steep decrease as you're delaying planting dates here in this region. So to maximize forage production, it is necessary to plant early. Now, as we're talking dual purpose systems, there is a trade-off because the earlier you plant, the lowest the grain yields tend to be. So producers really need to find a balance between the best day to maximize forage production and to minimize grain yield losses due to early planting. Now, for this region, seems that about September 15th is a good goal to have that wheat planted, and for other regions in the Great Plains, I guess about 3 weeks to a month before that best planting date for grain only seems to give an adequate planting date for dual purpose production. Now, another management practice that we need to keep an eye on is really planting depth. So as we planted early, it's often going to be planted into drier and hotter soils. It's not uncommon actually to sow wheat into 100 degrees Fahrenheit soil temperatures. So whenever we're in this scenario, we have 3 things to be considered here. 1, seed dormancy, as we're planting earlier than optimal. 2, high temperature germination sensitivity. And 3, a decreased coleoptile length, as we're planting into hotter soils. So really, when you talk about seed dormancy, it occurs naturally in most wheat varieties. So this condition is just a condition in which the seed will not germinate even under favorable moisture and temperature conditions. So overall, seed dormancy is a very good thing. It helps prevent pre-harvest sprouting, as you can see here in this picture to the right. The highest level of seed dormancy generally occurs just before harvest, and it's gradually lost with time. So that by October, generally the post-harvest dormancy should have dissipated in most wheat varieties. Now, when sowing early for dual-purpose production, say early September in some regions, there will be less time between harvest maturity and sowing, so that seed dormancy may not have completely dissipated by then. So this really is one issue that we need to be aware of when planting wheat early. The second factor that I mentioned would be that we need to take into account as well high temperature germination sensitivity. This, in other words, means that some varieties will not germinate under hot soil conditions. And this event really differs from the true seed dormancy because a cool rainfall event, for example, it may overcome and may lead to germination, for example. So it differs from true seed dormancy, but it's an event where some varieties will not germinate with hot soils. So high temperature germination sensitivity is variety specific, and there is great variability between varieties, as you can see here in this chart. Varieties that are more sensitive to hot soil conditions, such as overly 2174 or even centerfield, should not be sown early with the risk of decreasing germination and stem establishment as well. Finally, the third factor we need to consider when planting early is decreased coleoptile length. So what is coleoptile? The coleoptile is a rigid protective structure that covers the emergent shoots, as you can see here in this representation to the left. So what happens once the coleoptile reaches the soil surface, it stops growing and the first true leaves emerge. So, and this is represented here in the picture to the right. So the problem with early planting is that hot soils often decrease the coleoptile length. And in case the coleoptile does not reach the soil surface, the first true leaf emerges below the ground and the wheat plant typically dies. And here we have a picture that is a clear example of that. So the wheat plant on the top of the picture has kind of this accordion-like leaf, which is a typical symptom of when the coleoptile did not reach soil surface and that leaf came out still below the surface, the first true leaf. Now, if you check the wheat plant below, you will see an elongated coleoptile, but that reached soil surface and allowed the first true leaf to be exposed. So really the main problem with this is that our modern semi-dwarf wheat varieties, they already have a shorter coleoptile length than some of the old tall varieties. So it already increases the likelihood of that coleoptile not reaching the soil surface in hot soil conditions. Varieties differ in their coleoptile length, as you can see here on the left, another publication put by Oklahoma State on this issue. And so one of the options is to try to avoid some of those very short coleoptile varieties. So really going back to planting depth, one of the considerations here is to never plant deeper than the coleoptile length, especially when planting early because we're planting into hot soils. And second, that there hasn't been really, if there hasn't been a considerable precipitation event in the last few days, and there's no moisture within that first inch to inch and a half of the profile, it's usually better to plant shallower and wait for rain, or in other words, dust the wheat in, than to plant deeper, because the chances are that the decreased coleoptile length will not allow for the coleoptile to reach the soil surface if planted deeper. Some of the other consequences of an early planting wheat, typical on these dual-purpose systems, is increased incidence of fall insect problems. So I'm not going to go into much detail into these, but I'll just show some of the possible insect-related problems that can be a consequence of early sowing of wheat. One example here is a Hessian fly that can really decrease with yields, increase with lodging. So with early sowing, it increases the risk of Hessian fly problems, so that there is what we call the Hessian fly free date, which generally was the date of the first freeze event, right? As we're in dual-purpose systems, we're generally planting before that date. So we need to take that into consideration. And as far as control, the genetic resistance is generally the best defense that we have here, as seed treatments generally do not provide season-long protection. Also, aphid-related problems are more likely to arise when we're planting wheat early. Aphids transmit the barley yellow dwarf virus, and those fall infestations of barley yellow dwarf can be really devastating to the wheat yields. So if critical levels of aphid are measured, it might be a good idea to chemically control, as long as insecticide seed treatments may only prevent infestation the first 15-30 days, so not too efficient if aphids continue to appear after that period. And the last insect problem that I'm going to touch on today here is wheat curl mite. When that can transmit wheat streak mosaic. So the wheat crop mite generally requires what we call green breach to infect the wheat. So this green breach, it can be wheat, volunteer wheat, can be corn or grain sorghum or even other species. And it is recommended that this green breach must be eliminated if the plant is actually dead at least 2 weeks prior to planting the wheat crop. So this can be really more challenging when we're planting wheat early in dual-purpose systems. So some of the other considerations that we need to take when growing wheat for dual purpose are related to soil fertility and nutrient management. So today I'm going to discuss the role of soil pH, phosphorus, and nitrogen management, and how these are affecting forage production, and also how to manage these whenever we're growing wheat for both forage and grain. So I'm going to start with soil pH for two main reasons. First, low soil pH have been increasing, so it's an increasing concern in the majority of the area where wheat is grazed, including central Oklahoma, south central Kansas as well. And the reason for low soil pH in these regions really related to continuous wheat production and nitrogen fertilization, which contributes to that low topsoil pH. The second reason is because soil pH will really impact the availability of all the other nutrients that you can see here in this chart. So the availability is especially impaired at low soil pH. Generally, soil pH levels below 5.5 to 6. And also, there is an exponential increase in aluminum availability when the soil pH decreases below about 5.5, as you can see here in this graph. So this increase in aluminum availability will have a few consequences, right? Especially it's going to decrease the wheat root growth. So with less root, the wheat crop will be able to explore less the soil for both water and nutrients, and really is going to decrease the top growth as well. So the decrease in root growth combined with that decrease in phosphorus availability, it's really going to impair wheat development, as you can see here in this picture. So much less root development, much less tillering, much less forage production whenever growing wheat in low pH soils. In fact, we conducted a study while I was still at OSU together with Brian Arnau and Jeff Edwards, where we're looking at the effects of a soil pH gradient in wheat forage and grain yield. And in this study, we were evaluating 4 different wheat varieties grown in soil pH gradient ranging from about 4 to 8 in a dual-purpose situation. And there was really a very sharp decrease in wheat fall forage yield, as you can see here in these charts, whenever soil pH levels fell below about 5.5 to 6, really depending on which variety we were growing. So to be on the safe side, what we can recommend is that soil pH must be maintained above about 6 to maximize wheat forage production in these dual-purpose systems. So this graph shows you how the study, you can really see the sharp decrease as the pH went below 5.5 to 6. Now, how did this look in the field? You can see here on this photo, and you can see that here on these 4 plots, we had the target pH of 4, wheat forage production was really, really decreased. The next 4 plots had the target pH of 4.5, and wheat forage production was still low, and so on and so forth. As far as wheat grain yield, following grazing termination here, and this was a simulated grazing, but wheat grain yields, they were not. There wasn't really such a clear relationship as we saw with forage. You can see here on these graphs, the critical soil pH to maximize grain yields, it ranged in between 4.8 to 5.8, depending on variety sensitivity as well. So this really showing us that wheat yields or grain yields are a little less sensitive than wheat forage yields to acid soils. So really some conclusions about managing soil pH for dual-purpose reproduction. Forage is more sensitive than grain yield to low soil pH, so we do need to aim and try to keep the pH above about 6, so we're maximizing both forage and grain yields. So to keep this pH at these levels, it is recommended to soil sample at least, say, about 2 years, and assess the current soil pH conditions, apply agricultural lime according to the university recommendations. Now, in cases when the investment in lime is not doable, say, this year, blending pea fertilizer in furrow can be an option to try to alleviate some of this low pH and increase with forage production as well. So this really leads us to the second topic within soil fertility here, which is soil phosphorus management. So generally when I talk about dual purpose wheat production and soil phosphorus, I like to quote something that I heard from Brian Arnall once, which goes more or less like in furrow phosphorus is money in the bank. And in fact, providing those seedlings with that banded phosphorus is much more, makes phosphorus much more available, especially in low pH soils, that can really improve with emergence, early season root growth, and tillering, and consequently forage yield as well. And generally, adding about 50 to 60 pounds per acre of diammonium phosphate or equivalent from other sources should get the job done. So this graph here really shows us the effect of different lime strategies on wheat percent green canopy cover on a low pH soil. So this soil had a pH of about 4.7. You can see that, well, percent green cover, as we commented before, it's a largely function of the amount of tillering, and it's highly correlated with forage yield. So here you can see that 50 pounds per acre of banded DAP, diammonium phosphate, resulted in the greatest green canopy cover, even greater than lime in this case. So that's the green line as compared to the blue line here. So also showing that banding P may be an alternative when, for example, leasing ground to avoid that long-term, we can call it commitment of liming, right, and that long-term investment of liming. Finally, some thoughts here on nitrogen fertility for dual-purpose wheat production. Bottom line here is that dual-purpose wheat will require more nitrogen than grain-only wheat, especially during the fall. So a good rule of thumb is that about 30 pounds of nitrogen per acre are required for each 1,000 pounds of forage per acre to be produced, or for each 100 pounds of beef per acre to be produced. Those are current recommendations, right? So, and then additionally, we need the supplemental nitrogen applied prior to jointing to complement grain yields. We do have, well, currently Dorivar, who is Diaz here at K-State, he's got a project looking into fine-tuning some of these nitrogen recommendations whenever it's grown dual purpose, which is also part of the Grazing Cap project. So he's including some sensor readings among other technologies to try to fine-tune the nitrogen recommendation for dual purpose production. So as far as the grazing management itself, we'll discuss a little bit about grazing initiation, grazing termination, and some thoughts on livestock management as well. So as far as grazing initiation, grazing should not be initiated before a good development of the secondary root system. So as you can see in these pictures, developing wheat plant has both seminal roots and crown, or what we call secondary roots. The secondary roots are the ones that will actually be responsible for absorbing most of the water and nutrients for the plant throughout its life cycle. But it's especially important in dual purpose system because they're going to anchor the wheat plant to the soil. So they're going to avoid that whole plant removal by the cattle. Both of the plants in this picture are actually way too young to be grazed. Neither of them has a good secondary root system developed yet. We generally think of a minimum of about 6 to maybe 8 inches of top growth needed before grazing initiation. But it is really important to remember that good top growth will not necessarily indicate a good root anchorage. So really the best way to determine if plants are anchored enough is to really pull a few of those whole plants out of the ground and evaluate the root development. So as you can see here in these pictures, we have one example on the left in which we would still like to see some more root development prior to initiate grazing on this crop. while the plants on the right should already be well anchored. You can see by the amount of secondary roots. So these would most likely not be removed by cattle. So some considerations now on the livestock management side of grazing wheat pastures. Well, both stocker cattle and mature animals can graze wheat pastures, but due to the high quality of the forage, there's generally greater profitability if we're grazing it with stockers or fall calving cows. So optimum stocking rates will depend again on the environmental conditions that we had for fall forage production, as well as on wheat management. But on average, some previous case state data shows that wheat pastures will allow for a stocking rate of about 1 to 2 acres per stocker during fall and winter, and about 0.75 to 1.3 acres per stocker during the spring. So these stocking rates can possibly be increased by providing dry feed, again, because of the high quality of wheat pastures, so providing, say, grass hay or silage or some limited grain. And some data here from K-State also supports daily gains ranging between 1.5 to about 2 pounds. So grazing termination, that's a very important point that we need to remove cattle, otherwise we're going to start hurting our wheat yields. So in order to minimize the yield losses that are associated with grazing, it is really important that cattle is removed by first hollow stem. So in the past, cattle was generally removed at a fixed date, say March 15th, or in some cases when wheat was joined. But there's some research that has demonstrated that jointing is already late. So the yields are already being reduced if we're only removing cattle then. So what is first hollow stem? First hollow stem, as you can see here in these pictures, it occurs when there's about 1.5 centimeters, or say about half an inch, of hollow stem present below the developing wheat head. As you can see here in this picture, the plant to the left is already at jointing, so it is past first hollow stem, while the plant on the right is about 1.5 centimeters of hollow stem below the developing wheat head. Luckily, 1.5 centimeters is equivalent to the diameter of a dime, so this really makes life easier. So how do we check for first hollow stem when out in the field, right? It's very important to check from ungrazed areas of the field. Again, because grazing will delay the appearance of the first hollow stem. It's going to delay crop maturity, as we have previously talked about. And these ungrazed areas may be found either on field corners or just outside the electric fence that have not been grazed. Very important to be from the same field with the same variety, but needs to be ungrazed. And we generally check for the first hollow stem by digging 4 or 5 plants from these ungrazed areas, splitting the largest tiller lengthwise, starting at the base, and measuring how much hollow stem is present below that developing wheat head. And here's a couple more pictures from Jeff on this specific stage. So this happens towards the end of 6 growth stage 5, just prior to jointing. You can see really clearly about 1.5 centimeters of first hollow stem here. So grazing past first hollow stem, it's going to result in yield reductions. These yield reductions, they can yield anywhere from about 1% to over 5% per day, really depending on conditions for regrowth. So if at grazing termination those conditions are cool and wet, they will be more favorable for wheat recovery. So grazing past first hollow stem under these cool and wet conditions will have less effect on grain yields. So generally we're looking at maybe 1% per day their yield reduction. Now, if we're grazing past first hollow stem in dry and hot and some harsh conditions, that will really accentuate the yield losses. So these yield losses can be up to 5% or more per day. Right? So that's why checking for first hollow stem is very important. So we're making sure that we're sustaining our wheat yields. So the question is, do I need to be out checking for first hollow stem for a full month? from late January now up to early March. Well, maybe in the past. Now we do have a tool that was developed by the Oklahoma Mesonet that can help producers narrow down that window that they need to be out checking for first hollow stem. So here you can see the first hollow stem advisor, which can be accessed from the agriculture section of the Mesonet website. And this product, what it produces is actually a prediction of the probability of first hollow stem. So within the next 2 weeks, right? So what's the probability that my crop is going to achieve first hollow stem in the next 2 weeks? As you can see in the chart here, 5%, 50%, 95% probability. So we really know that, well, we should be out checking and really thinking about removing the cattle. And these predictions really done based on current weather during the growing season, historical weather averages for that location for the next 2 weeks, and also depending on which wheat variety that is being grown. So generally they are grouped into early, medium, or late first hollow stem varieties. As part of the Grazing App as well, the model developed by Oklahoma Mesonet, we're currently validating it for Kansas conditions. So we're looking at first hollow stem South Central Kansas. So if that model really predicts the behavior of the different varieties well here up north, this may be a possible collaborative product for Kansas producers in the near future as well. Okay, so getting into the third major topic I'll discuss here today with you, what are some interesting varietal traits for dual purpose wheat? And really the response to this question has already been partially discussed in some of the slides that I showed you previously. So these traits, they include, again, the ability to germinate well under hot soil conditions, or choosing a variety that is not high temperature sensitive. Date of first hollow stem. So these will allow, like if you choose a variety that's a little bit late on the first hollow stem, can allow up to 2 to 3 weeks more of grazing into the spring. Always keep in mind that some of these varieties will reach first hollow stem very early, like Overly or OK Bullet, and some other varieties may be up to 3 weeks late, such as like Endurance or 2174. So currently, Oklahoma State University puts out a yearly report on date of first hollow stem for several wheat varieties. This can be accessed online, and this is a report that we're looking forward for the future here for Kansas State to be putting yearly as well for different varieties, looking at a little bit different conditions, South Central Kansas. Another very important trait is with grain yield potential after grazing. So is low soil pH, aluminum tolerance, due to the detrimental effect of these aluminum and soil pH on wheat forage yield. We also commented a little bit about the longer coleoptile. So this can help compensate for some of the decreased coleoptile length that is led by hot soil temperatures. So this should be something to be taken into consideration as well. As far as forage yield, most of the current wheat varieties, they are good forage producers. So in fact, generally environmental conditions like temperature and moisture, they are often going to lead to much greater differences in forage yield than varietal differences. But there are varietal differences in forage production as well. So this can be accessed with information produced by Oklahoma State University, and here in the near future from Kansas State as well. As far as white or red winter wheat, again, some research done here in Southwest Kansas by John Holland has shown that really doesn't matter if it's a white or red winter wheat, both are responding similarly to grazing. So producers have this option to choose and grow a white wheat or a red wheat, regardless if they want to graze or not. And this leads me to the final part of this presentation, where we're going to discuss using Canopeo smartphone application to manage grazing intensity. So Canopeo is a smartphone application that was developed by the soil physics group at OSU, working under Tyson Moxner, and this was an effort mainly led by Anders Patrignani. Andres will be joining us here in K-State in May. So Canopeo is free to download for either iPhone and Android. And what it does, it quantifies how many pixels within a given image are green and how many are not. So it really gives a very precise estimate of the total percent green cover, as you can see here in these pictures. So the upper picture here having about 88% green canopy cover, and the bottom picture about 18% canopy cover. It's a very handy app to have, and really gives a precise estimate of the total green cover. It is also able to differentiate what is dead tissue from what is green vegetation. So if you look closely to these images, you'll see that some dead tissue was not quantified here. So it gives a very good indication of what actually is green. So what's the percentage of green that we have. Okay, so I know what's the percent green canopy cover on my field. What do I do with it? How do you use it, right? And these, I'll go back to those graphs that I showed you earlier during this presentation, which are showing the relationship between relative wheat yield and fractional green canopy cover. So what this research has shown was that maintaining fractional green canopy cover above about 50% during fall and above about 60% at grazing termination or first hollow stem here should help sustain wheat yields relative to an ungrazed control. So in order to estimate, how we can use Canopeo here is really to estimate what's the wheat pasture's percent green canopy cover when we're reaching first hollow stem or before that, so we can manage and maintain the green canopy cover above this threshold. And really, all that is needed to take that estimate is to go out to the wheat pasture, open the app on your smartphone, and then as you can see here on this picture, mainly extending the arm to the side, so the shoes are not included in the picture. That seems kind of obviously, but it's very important to mention. Hold the camera parallel to the ground, about 2 feet above the crop canopy, and taking the picture. So the number of pictures to be taken are going to vary from field to field, and that's going to depend on field uniformity, and generally the more pictures the better. But some preliminary data that we have been collecting indicates that about 5 to 10 pictures of a pasture should be able to account for most of that within field variability and gives us a reliable estimate of the green cover. So really it's a free app, very handy tool that producers can have and just on their phone and take, as they walk down the wheat pasture, take 10, 5, 10, maybe 15 pictures and have a very good estimate of that percent green cover. With this really wraps up this webinar. I have here a list of references that was used to come up with this presentation, if you're interested. Also, there's a list here of some interesting resources for grazing wheat pastures, including both K-State and Oklahoma State wheat websites, the Canopeo website itself, and both the Mesonet websites. Again, I really thank you for joining us today here for this webinar, and I'll be glad to take any questions that you might have. Here you have my contact information, so feel free to shoot me an email as well, and follow me on Twitter at KSU Wheat. Thank you.